Howdy everyone. We are Team Triple N. We are excited to share our research on emotional speech dataset classification, recognizing using spectrogram image method. We choose this project by understanding the importance. Emotional speech recognition is a field with immense potential, offering application in various industries including healthcare, customer service, and entertainment. As a matter of fact, we as a team, we were motivated to impact the accurate emotion speech classification could have improving computer human interaction and enhancing user experience. Over here we are a team member, a team triple N, Naveen Chella Pandi, Jirapong Chalotonpised, Kumaravel Saranraj, Huang Lianchen, Sougri, Zida. Content of this presentation will be covering introduction, dataset used, additional information about dataset, block diagram of the proposed model, and each and every block diagram in brief, MO dataset, spectrogram image, model, classification accuracy, classify emotion, and in the end, reference work and proposed work comparison. Talking about the introduction of our project, speech emotional recognition plays an important role in automatical driven application areas such as robotic system. This project presents an approach to detect emotion of speech based audio files using deep learning approach. The existing implementation of speech emotion recognition has a limitation of not achieving high accuracy, and therefore there is a scope of accuracy improvement by making fine adjustment on the existing model. And the advantage of this project is enhancing human interaction, personalization, safety and well-being, efficient task performance, education and therapist application, human machine collaboration, marketability, and user acceptance. In this project, our primary goal was to develop an effective model for classifying emotion in speech using spectrogram image method. The challenges that we come across throughout the project, we faced and overcome challenges including data processing, featuring extraction, and model optimization. Now, let's dive into the data set that serves as the foundation of our project, the MODB dataset. The MODB dataset was meticulously crafted by the Institute of Communication Science at the Technical University in Berlin, Germany. It stands as a valuable resource for our exploration into emotional speech recognition. 10 professional speakers comprising of equal distribution of male and female actively participated in the recording sections for this database. The richness of this MO dataset is reflected in the vast collection of 535 utterance. These utterance provide a diverse and comprehensive set of vocal expression for our analysis. What makes a MODB particularly interesting for our project is it's the comparisons representation of emotion. The dataset compress even distinguish emotional states such as anger, boredom, anxiety, happiness, sadness, disgust, and neutral. To ensure the feasibility and fidelity of the recorded emotion, the data was captured at a impressive 48 kilohertz sampling rate. Subsequently, to align with our project requirement, the dataset was downsampled to a 16 kilohertz rate. Before we dive deeper into the our project methodology, let's take a moment to understand the unique naming scheme used for each utterance in the MODB dataset. The utterance in the MODB dataset follows a consistent naming convention, providing valuable insight into the content. Let's break down the element of the naming scheme. Position 1 and 2. The first two position represents the number assigned to a speaker who deliver the utterance. Position 3 to 5. The following three position consist the code of the text spoken by the speaker. The sixth position indicates the emotion conveyed in the utterance. Specifically, W, L, A, F, T, E, N are being denoted for W is for anger, L for boredom, A for anxiety, F for happiness, T for sad, E for disgust, N for neutral. If there are multiple versions of the same utterance, they are distinguished by the seventh position. which is denoted by a letter A, B, C, and D, or 4. Now, we have described the naming or naming scheme. Let's move forward and explore the processing step and understand to make the diverse data set suitable for our model. Now that we have the solid understanding of the MODB dataset, let's walk through the block diagram of our approach. For MODB to spectrogram image application, our model finalizing the acceptance classification accuracy. In this project, we delved into the classification and recognition of emotion in speech using a unique approach, a spectrogram image method. Why spectrogram? Spectrogram image provides a vital representation of speech signal, allowing us to leverage the power of image processing and deep learning for accurate emotional classification. So the MO data set will be processed, and we will be obtaining the spectrogram image, and the acquired spectrogram image will be given to the applied model, the proposed model that we are using in our project, and then we will be getting a classification accuracy, and based on that, in the end, we can say what kind of emotion this speech represent in the end.
As my teammate has spoke about the emotional dataset, you can see from the screenshot that there are 535 utterances. These are the voices file we will be taking as an input to generate spectrogram. And now we move on to the spectrogram images. The male frequency cepstral coefficients or MFCC features of spectrogram images are also extracted, which provides input to the modified CNN model. Spectrogram images are generated from speech samples from the German emotional database dataset. For our model, a modified convolutional neural network model is used. This modification includes additional convolutional layers, dropout layers for regularizations, and adjustments to parameters like filter size and so on. Experiment with these modifications based on the characteristics of the emotional database dataset used. Hyperparameters such as dropout rates and the number of filters are adjusted, which allows you to fine-tune the model's performance. For the classification accuracy, the modified CNN model, which is used for speech emotion classification, results in an improvement in the accuracy value to 92%. We can see a graphical analysis of training and testing of loss and accuracy, and the classification results of speech emotion recognition represented in the form of a confusion matrix. For classifying emotions, as you can see from the confusion matrix, the predicted label and the actual labels are very close. The most accurate one of this model is the sadness in the voice. For our reference work and proposed work, the existing implementation of speech emotion recognition has the limitation of not achieving high accuracy, and therefore there is a scope for accuracy improvement. By making fine adjustments to the existing model, German emotional database dataset was used to perform the experiments. The proposed system gives an accuracy of 92% as compared with 86% accuracy of the existing model. And as you can see from the right side of the proposed work, we use a modified CNN model, which is a type of deep learning model designed for processing and analyzing visual data, making it particularly effective for tasks such as image recognition, object detection, and to some extent, speech and signal processing like speech emotion recognition. In this paper, here is the modified CNN model used during the experiments. Thank you everyone for your attention.